Hello there, welcome to Cool Talk Talks. We are on number 2 of the series of the 100 most influential persons of all time, as per Michael Hart. Now, these are not necessarily the greatest or the best, but they are the most influential. My last video, I explained why Michael Hart considered Muhammad, leader of Islam, the most influential person who ever lived. And now we have come to number 2. Isaac Newton, the greatest and most influential scientist who ever lived. Life would be very, very different if he had not existed. Isaac Newton was born in 1643. About a century before him, Europeans considered Aristotle's teachings and rarely contested them. Then philosophers René Descartes and Francis Bacon stated that it was time to challenge these views. Then scientist Galileo took this to heart. Galileo was an astronomer, physicist, and engineer, often called the father of modern science. Galileo taught and believed in Copernicus' heliocentrism, that the earth rotated around the sun, and not that the sun rotated around the earth, which was believed by scholars and the Catholic Church. Galileo was accused of heresy, tried in the Inquisition. He was forced to recant and placed under house arrest for the rest of his life. He died the same year that Isaac Newton was born. Newton was born in Wilsthorpe, England. Now, Newton did not excel in school, and his mother thought he should become a farmer. But he did pursue academics and eventually entered Cambridge University. He absorbed science and mathematics and began his own independent research, laying many of his scientific theories by the age of 27, revolutionizing the world. One of Newton's groundbreaking achievements is his observations that brought about the laws of motion. There are 3 of them. Number 1, objects that are in motion stay in motion. Objects that are at rest stay at rest, unless acted upon by an unbalanced force. Number 2, force is equal to mass times acceleration. So, if you change one variable of this formula, you change the other variable. If you double the force, you double the acceleration. This formula came in very handy when we developed engines, especially fuel-powered engines or even steam-powered engines. You need to know how much force you need to move an object of a certain size. Law number 3. For every action, there is an equal and opposite reaction. Newton applied these laws when he studied motion and mechanics, and he actually still used it when he studied the nature of light. He concluded that light is actually a line of motion made up of small particles, and he concluded that white light was a result of a mixture of all the colors of the rainbow. Then he analyzed both the refraction and the reflection of light and built the first reflective telescope. Before this reflective telescope, all telescopes were refractive. They were bulky, they were heavy, the images got distorted. Reflective telescopes like Isaac Newton's are what is still used in the largest modern telescopes that we use today. The lenses are much less heavy, and we avoid any problems and distortion of images that the refractor lenses brought in the past. You've probably heard the story of how Galileo discovered gravity because an apple fell out of a tree and landed on his head. Well, the apple probably didn't land on his head, but it did fall, and it made him think and ponder why the apple didn't fall up. Why didn't it fall sideways? Why did it always fall down? And he concluded that every object in the universe, every object, every person, every animal, everything attracts every other object and every other thing with a force directed along the line of centers. This is the law of gravity, and he backed it up with mathematical formulas and proportions. Newton always gave us mathematical formulas to back up his ideas, and Newton created these calculations. So let's discuss math, because what I'm about to tell you is mind-blowing. You remember in school how you had to calculate the area of a rectangle by multiplying the base times the height. For example, this rectangle, it has sides of 3 and 4, multiply them together, and the area is 12. Simple, right? But what if you wanted to find the area of an item like this, with a slope? You couldn't do it with regular math and possibly not even with algebra. Newton wanted to be able to calculate it, develop formulas for it. He also wanted to calculate the rate of increasing speed that an object develops when it falls, or how to calculate where a celestial body will be at a certain point. He wanted to measure the ellipsis of the orbiting planets. You couldn't do that with the existing math of his time. So what did Isaac Newton do? Did he throw his hands up and say it couldn't be done? No, he developed another math, integral calculus. Without calculus, not only would he never have developed some of the laws and formulas that he did, but many of the inventions that followed would never have been made. Think about Newton's contributions to the laws of motion, his study of light, optics, telescope, space exploration, and all that came with it. Think about it. Once he invented the integral calculus, scientists ran with it and the world changed. Today, without calculus, we would not have GPS systems. We would not have televisions. We would not have radios. We would not have ultrasounds. We would not have microwaves. We would not have cell phones. And he did this. He invented calculus at the age of 24. It is hard, if not impossible, to overstate how revolutionary and how astonishing this accomplishment is. Calculus is used in physics, chemistry, biology, economics, mathematics, engineering, pretty much all sciences, and has opened up new branches of science. Calculus studies the rate of change of a quantity over time. Think of space exploration and all the things that this has given us. For example, instant television, satellite TV, live events can be seen worldwide instantaneously, such as sports events, award ceremonies, and sadly, terrorist attacks and war. In meteorology, weather forecasting has vastly improved using satellites that we can use to monitor droughts in one continent, floods in another, and hurricanes crossing the oceans, helping save thousands of lives. Jets and ships can pinpoint landfalls with mobile phones and GPS systems to guide explorers with precision. And Germans are testing cars with hydrogen. Space platforms are monitoring our environment. Miniaturized technology has aided medical health in the field of robotics. Now, much has been said of Newton's passion, some say obsession, over alchemy. Some views this as the occult. He also wrote extensively on biblical prophecies. If anybody asked him when the world would end, Newton said that the world would not end anytime before the year 2060. All that is just a side note. Now, we don't have time to enumerate all of Newton's other achievements, his great contributions to thermodynamics and acoustics, more discoveries in mathematics, his clear and concise explanation for the origins of the stars. And more than that, he also left a unified system of laws. Because before this, science was basically a lot of mixture of isolated facts and laws. Well, Newton brought them all together. We can assess Newton's importance this way. Humans lived in the year 1500 AD, much the same way they lived in 1500 BC. But after Isaac Newton, when other scientists took his observations and ran with it, modern science has exploded at an ever-increasing rate. And we now dress differently, eat differently, live longer, have different jobs, spend our free time doing different things. Science has revolutionized technology, economics, politics, religious thinking, art, philosophy. Virtually everything has been affected by modern science. Now, there have been negative impacts. We can talk about the destruction of the environment, and at a more basic level, the family structure has changed forever. Men and women have either thrown away, don't know, or are confused by what their role in the family is. Nevertheless, positive or negative, this counts as an influence from modern science. Newton died in 1727. He was 86 years old. And now, in my next video, we will talk about the third most influential person who ever lived, Jesus. And why wasn't he considered by Michael Hart to be number one? I discussed that in my last video. I will discuss it further in my next video when we talk about the influence that Jesus and Christianity had on the world. In the meantime, send me your likes, comments, or better yet, subscribe. This is Cool Talk Talks.